Hi, I'm Shyamala Gauri, Assistant Professor, CSE in Rohini College of Engineering and Technology. Subject code CS3491. Subject name Artificial Intelligence and Machine Learning. Unit 2 Probabilistic Reasoning. In this presentation, I'm going to explain about probabilistic reasoning. It is a way of knowledge representation where we apply the concept of probability to indicate the uncertainty in knowledge. In probabilistic reasoning, we combine probability theory with logic to handle the uncertainty. We use probability in probabilistic reasoning because it provides a way to handle the uncertainty that is the result of someone's laziness and ignorance. In the real world, there are lots of scenarios where the certainty of something is not confirmed, such as it will rain today, behavior of someone for some situations, a match between two teams or two players. These are probable sentences for which we can assume that it will happen but not sure about it. So here we use probabilistic reasoning. Need for probabilistic reasoning when there are unpredictable outcomes. When specifications or possibilities of predicates becomes too large to handle. When an unknown error occurs during an experiment. In probabilistic reasoning, there are two ways to solve problems with uncertain knowledge. One is Bayes rule, second one Bayesian statistics. Bayesian reasoning. Bayes theorem is also known as Bayes rule, Bayes law, or Bayesian reasoning, which determines the probability of an event with uncertain knowledge. In probability theory, it relates the conditional probability and marginal probabilities of two random events. Bayes' theorem was named after the British mathematician Thomas Bayes. The Bayesian inference is an application of Bayes' theorem which is fundamental to Bayesian statistics. It is a way to calculate the value of P of B by A with the knowledge of P of A by B. Bayes' theorem allows updating the probability prediction of an event by observing new information of the real world. Bayes' theorem. The formula is explained below. That is, P of A by B is equal to P of B by A into P of A divided by P of B. The above equation is called Bayes' rule or Bayes' theorem. This equation is basic of most modern AI systems for probabilistic inference. It shows the simple relationship between joint and conditional probabilities. Here, P of A by B is known as posterior, which we need to calculate, and it will be read as probability hypothesis A when we have occurred on evidence B. P of B by A is called the likelihood in which we consider that hypothesis is true, then we calculate the probability of evidence. P of A is called the prior probability, probability of hypothesis before considering the evidence. P of B is called marginal probability, pure probability of an evidence. In equation A, in general, we can write P of B is equal to P of A into P of B by AI. Hence, the Bayes rule can be written as P of AI divided by B is equal to P of AI into P of B by AI divided by summation of I is equal to 1 to K P of AI into P of B by AI, where A1, A2, A3 up to AN is a set of mutually exclusive and exhaustive events. So, probability of cause divided by effect is equal to P of effect by cause into P of cause divided by P of effect. Here I have shown one example. I have explained one example. What is the probability that a patient has diseases meningitis with a stiff neck? Here given data is a doctor is aware that disease meningitis causes a patient to have a stiff neck and it occurs 80% of the time. He is also aware of some more facts which are given as follows. The known probability that a patient has meningitis disease is 1 by 30,000. The known probability that a patient has a stiff neck is 2 percentage. Let A be the proposition that patient has stiff neck and B be the proposition that patient has meningitis. So we can calculate the following as P of A by B is equal to 0.8, P of B is equal to 1 by 30,000, P of A is equal to 0.02. So when we calculate P of B by A, we arrive the result is 0.00133. Hence, we can assume that one patient out of 750 patients has meningitis disease with a stiff neck. Applications of Bayes theorem. It is used to calculate the next step of the robot when the already executed step is given. Bayes theorem is helpful in weather forecasting. Last one, it can solve the Monty Hall problem. Thank you.